question 8. Got a hyperbola and a straight line. Much like we did in the last question, but this one's intersecting the axes and questions feel a little bit more involved. So let's see what we've got. Let's run through the points and see if we can make sense of things. We've got this hyperbola and we're given the equation. From our equation, do we know anything that's not represented here? What does this minus 2, this p and this q tell us? P tells us if it's moved left or right. So the minus 2 tells us that it's moved right by 2, like doing the opposite. So if it's moved right by 2, you normally have an asymptote here. So we know that there must be an asymptote sitting here, and an asymptote sitting at x equals 2. Because x can never be 2. Because if you put 2 in there, 2 minus 2 is 0, it can never divide by 0. Okay, and the minus 1 is our q value. It's moved down by 1, so we've got an asymptote sitting here at y equals minus 1. Never quite reach there. This will never quite be 0, so we'll never quite get to minus 1. Okay. Straight line, we're not given much. That c value, well, that's the y, relates to the y-intercept. So if we can figure out a, you know its x value is 0, it's going to be useful because we can just find out what c is. Okay, d and b. A is also where the two graphs are equal to each other. It's also the y-intercept of the hyperbola. Well, if it's the y-intercept and we've got the full equation, we can just substitute x equals 0 and we can find out that value. I'm sure it's going to be necessary at some stage, and with so many questions, I'd be tempted, let's just find it out. We can put in the diagram. F of 0 equals minus 4 over 0 minus 2 minus 1. So wherever we see an x, we're substituting with 0. So 4 over minus 2 is minus 2, becomes plus 2, minus 1 becomes 1. That was a mouthful, right? So with a bit of luck, we punch it in the calculator. Minus 4 over 0 minus 2 minus 1 equals 1. Cool, we're happy. So in other words, this point 0, 1 is on the graph 0, 1, in which case we already know that c equals 1 from this. I can put it here, c equals 1. So we know that g of x equals mx plus 1. Really up to you. You really do not have to work anything out yet until you see the questions. Sometimes it's safer to read the questions because they guide you through, but sometimes it's nice to have put down some of your own things. So when you get to the questions, you go, oh, no, I've got some more information in the diagram than I thought. So in what else have we got? B is an x-intercept or the x-intercept of the hyperbola. So we know that we don't know its x value, but its y value is 0. Now, I'm jumping ahead and I can see that we're going to have to find out b. So I'm going to work it out now already and go, so for b, our x-intercept, 0 equals minus 4 over x minus 2 minus 1. Add 1 to both sides. And there are going to be a few steps here. Add 1 to both sides. So we've got plus 1 equals minus 4 over x minus 2. This minus is bugging me. So I'm going to multiply the whole thing by minus and get minus 1 equals 4 over x minus 2. Just feels a bit simpler. Multiply by x minus 2. So we've got minus 1 times x minus 2 equals, that's a 2, equals 4. Distribute into the bracket. Minus x plus 2 equals 4. So x equals minus 2. So in other words, when x is minus 2, y is 0, we've just worked out what b is, minus 2, which means d is straight above it, so we know its x value. Can't quite work out its y value because we'd have to sub it into the straight line, right? A, we've worked out c. Okay, c is where the two graphs are equal to each other, or one of the places. So you'd have to make them equal to each other. That's definitely going to be what we do at some stage. This point they don't ask for, and that's it. Okay, so we found our bearings. In a test situation or exam, I'd suggest have a very quick look at what we've just done now, because it does take a little while. That was 5 minutes just to go through, although we've answered more than 5 marks with the questions here. So we've made up our time, but spend a little bit of time just going, okay, what's happening in the diagram? Okay, then we can get in. It's helped us now because we're going to fly through our question. Determine the asymptotes of the hyperbola. Done. X equals 2, y equals minus 1. In the diagram, we can write it here as well, but they're in the diagram. We're good. Determine the coordinates of A and B. A, done. A is 0, 1. B is minus 2, 0. Well, that is done. And that's, as I said, that's our 5 marks, probably 6 marks done, so we're caught up our time. Calculate the values of M and C if BD equals 5 units and D lies on the straight line. Okay, we've already worked out what C is. C equals 1. We worked out because it's related to the y-intercept. Okay, so we know that G of X equals mx plus 1. Now, how are we going to find out m? When m is gradient, and I'm not just jumping ahead and running and saying, well, m is rise over run, because we don't have 2 points. We don't know what c is, we don't know what d is, we've got its x value, we don't have its y value, so we can't just work out the gradient easily. But we do know bd equals 5. Okay, well, if this value is sitting down on 0 and this distance is 5, doesn't it make sense that that's just going to be 5? Because that distance is 5. In which case we've got 2 points, rise over run, our friend. M equals rise over run equals, how far are we running? From minus 2 to 0 is 2. How far are we rising? From 5 down to 1 by minus 4. So our gradient's minus 2, so g of x equals minus 2x plus 1. I'm going to put it up here, minus 2x plus 1. Determine, what have we done? Tick, 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 we've done so much. Determine the coordinates of C. Okay, for this we said where the graphs equal to each other, f of x equals g of x. I'm going to put this all the way across here because simultaneous, they take a while. F of x, when does f of x equal g of x? When does minus 4 over x minus 2 minus 1, when does that equal mx plus c minus 2x plus 1? And what we're just going to do, and continue to say, well, here we go, there's an equation to solve. I don't have this minus 1 here. Minus 1. And it's the sound of the birds outside. So we've got, what can we do? Well, we've got these fractions. Let's add 1 to both sides. You might solve this a little bit differently. It doesn't really matter. Minus 2x plus 1 gives us plus 2. I got annoyed by this minus, or you could leave the minus on top. Let's multiply the whole thing by minus. We've got 4 over x minus 2 equals 2x minus 2. Multiply the whole thing by x minus 2, or make that our lowest common denominator. 4 equals 2x minus 2, x minus 2. 4 equals, I'm half tempted to take the 2 out the brackets here. Anyway, let's just multiply across. 2x squared minus 2x minus 4x plus 4. So 2x squared minus 6x plus 4 equals 0. So divide the whole thing by 2. X squared minus 3x equals 0. X, I find simultaneous just take a long time. X equals 0, or that was too quick for the computer, or x equals 3. X equals 0. Now that we've work it up and got an answer, we're not surprised to see that as one of our answers, because x equals 0 relates to this, to A. So for C, we're looking at the other option where x equals 3. So we're looking at that one, so we can substitute that into the straight line or the hyperbola. I'm going to go for the straight line. G of 3 equals minus 2, 3 plus 1 minus 6 plus 1 minus 5. In other words, C is the point 3 minus 5. Whew. 3 minus 5. Okay. If you see a quicker way of doing that, please shout. The algebra just takes a bit of time. Can you see why I didn't want to do it earlier and just said we can see how to do it? It's going to take a while. Calculate the length of DC in third form. This comes out of nowhere, like we're in analytical geometry. So this, I'm going to move to over here. We said this is question E. CD equals, do you remember this long formula? This squared plus this squared minus. Subtract the x values, subtract the y values, punch into your calculator, and get an answer. So let's do that. Our x values. CD. 3 minus 2 minus 5 minus 5. 3 minus 2, 3 minus 5 equals, in the calculator it goes square root of 3 minus 2 is 5 squared plus 2 squared, square root 29. That was exciting. F's better though. F and G are nice. Determine the equation of the reflection of y equals f of x in the y-axis. Okay, so in the y-axis. So we're doing this and we're reflecting it this way. So whenever we had a positive x, we're going to have a negative x. When we had a negative x, we're going to have a positive x. But to work out what the equation is, whenever we saw an x, let's replace it with a negative x. So f of x, we're really looking for f of minus x now. So we're going to have minus 4 over, instead of x, we're going to have negative x minus 2 plus 1. So we saw an x, we replaced it with a negative x. Now we need to simplify this because we want an x on the bottom. So if we took a negative out of the bottom, we'd be left with x plus 2. Plus 1 means that negative and that negative become a positive. So we've got 4 over x plus 2 plus 1. You could look at this more conceptually and say, well, everything's going to stay the same except this asymptote is going to move to here. So in other words, we're going to reflect it, which means that it's going to look like a positive a value, and the asymptote's at minus 2, therefore it's x plus 2. I think it's a bit safer just to replace with negative x and algebra it up there. Okay, our last bit. Determine the equation of the reflection of y equals f of x in the x-axis. So we're going to take it, whenever we had a positive y, we're going to have a negative y. So instead of having y, we're going to make the whole thing negative. So for this one, kind of looking where we can squeeze this in right at the end here. So instead of a y, we're going to have a negative y. So the way some people do this, I actually don't like this way, is to go, instead of a y, we're going to have negative y. So minus y equals minus 4 over x minus 2 minus 1. So instead of a y, we have a negative y. And the other one, instead of an x, we had a negative x. Therefore, multiply this by negative 1, so we just have y. What you do on one side, you do on the other. So multiply this whole thing by negative, so it becomes positive x minus 2 plus 1. We've made everything that was negative positive. And again, conceptually, you could say we've reflected this about the x-axis. So our asymptote sitting over here at y equals minus 1 is now at positive 1. That matches our new graph. Our y value here, positive 1. Oh, it's gone off the screen a little bit there. Is positive 1, but our final equation we had was y equals 4 over x minus 2 plus 1. That's what I'm referring to up here. So plus 1, that makes sense. And this asymptote has stayed the same, so it's minus 2. it's reflected. So in other words, instead of a negative a, we're going to get a happy hyperbola if that's something doable, safer just to substitute in here. Let me zoom out and you can see that last piece of the puzzle. Looks like there we go. There's all our work. Beautiful.